When you're writing full and net ionic equations, you need to have your solubility rules up so you can figure out in the reaction which compounds are going to be aqueous, that means dissolved in a water, or which compounds are going to precipitate out, that means that they don't dissolve. So something that will dissolve in water we call soluble, something that will not dissolve in water we call insoluble. This picture here is what you're going to reference to determine if compounds are soluble or insoluble. That picture is also on page 413 of your book. So you can either reference this slide from your notes or you can reference that book. Okay, so I'm going to kind of slide up and down to see those. So I'm just going to start with my first two, silver nitrate and iron 3 chloride. So I'm going to do FeCl3 plus AgNO3. Because it's two compounds, this is a double replacement reaction. So you have to pull on that information from chapter 8. So this is a double replacement reaction. That means my positive and negative ions, they're going to like switch partners. So my iron will now be bonded to my nitrate and my silver will now be bonded to my chloride. So those are the two products that I'm going to write. Iron, we know, has a positive 3 charge if you calculate backwards from the chlorine. And then silver nitrate, nitrate we know is -1 because it's one of our polyatomic ions. So that makes our formula Fe3NO. I'm sorry. I was like, why does that look wrong? Sorry, guys. FeNO3. There we go. Okay. And then our other product is going to be the silver bonded to the chloride. So silver from our periodic table we know is +1, and then chlorine bonded to our periodic table we know is -1. So AgCl. So there's a couple things I need to do before I can start like the full and net ionic equation, or at least see if it's possible. So first thing I need to do is balance this appropriately. So 1 iron, 1 iron, I have 3 chlorine on that side, which means I need a 3 over here. That gave me 3 silver, and 3 nitrate and 3 nitrate. So with those 2 3s, I'm balanced. And then the last thing I have to do is assign their state of matter. So iron chloride, I'm going to come up here to my little table, and I'm going to find iron or chloride. Well, here I see chlorine. So it says chlorines are soluble except in these 3 circumstances. So that, since none of those are iron, this is soluble, which means I'm going to write AQ next to it. I should have left more room. If you're doing this, leave more room. I also have chlorine down here in my products, and I see that it's bonded with silver, which means that it's insoluble. So I'm going to write a solid. It's going to precipitate out of the solution, making it a solid. I'm also going to look up AgNO3. So I don't have silver anywhere, but I do have nitrate. It's my very first one here, and it says that they're all soluble. So anything with nitrate is soluble. So I'm going to write AQ on those. So is this a precipitate reaction? The answer is yes. I have 2 aqueous solutions, so in real life that would look like 2 liquids, and when I put them together I have a solid precipitating out. When we write that, you will see it written with like an arrow above. It just means that a solid fell out of the solution when you mix those 2 liquids together. So this is one that I'm going to go ahead and write a full ionic equation and a net ionic equation. I think the assignment asks you to do 8, so I'm doing 1 for you. So you need to find 7 more on the assignment to complete. So for my first one that I'm doing, I'm going to do the full equation first. So that means that I'm going to break up all of my compounds into their ions, except for the one that's solid. The reason I'm breaking them all up is because when you put a soluble solution into a liquid, it breaks up into its ions. That's why we call it aqueous. It doesn't form new compounds. It's not a reaction that's necessarily taking place. When the solid forms, that's when we see the reaction taking place. But just the breaking up of the ions is what we see when we add these things to water, and they're aqueous. So I'm going to write that I'm going to write each of them as their ions. So Fe3+, all ions are always aqueous. Ions don't float around. You have them in a solution, so their state of matter will always be aqueous. I have 3 chlorines, and chlorine is -1. Let's see, I have 3 silvers, and I know that's +1. And then I have 3 nitrates, because remember that 3 distributes, and that's -1. All right, again, I knew the charges either because they were polyatomic ions or I knew them from their placement on the periodic table. The only one that I had to calculate out was the iron. If you forget how to do that, head on back to chapters 6 and 7 where we learned that. My products, I have my iron nitrate, that's aqueous. So I have my iron 3+, again, it's aqueous, plus my 3 nitrates. Nitrate is -1, aqueous. And then finally, my other product is my 3 silver chlorides. I don't break those up into their ions because in the solution, it's not broken up in ions. It precipitates out as a solid. So I show that by leaving it in its full like molecular structure or balanced equation. All right, so now what I'm going to do is I'm going to like evaluate this full ionic equation, and I can see that here I have iron and here I have iron. Because it appears the same way on both sides of the equation, we call that a spectator ion. It facilitated the reaction of silver chloride. It facilitated making silver chloride, but it wasn't actually involved in the reaction, so we call that a spectator. Our other spectator here is nitrate. I have it the same way on both sides. So I'm going to cross out those spectators as well. So when I write my net ionic equation, my net ionic equation is the full ionic equation, just without the spectator ions. So I'm going to write down everything that I didn't cross out. So that's my 3 chlorines, I didn't cross that out. My 3 silvers, I didn't cross that out. And yielding my 3 silver chlorides. So that is my net ionic equation. I would like you to do the full ionic equation, cross out the spectator ions, and then write your net ionic equation. So all 3 of those steps for an additional 7. You can use the one I just did as your first one, which was creating this, right, silver chloride. So on the next one, you can move over to lead chloride or down to silver iodide. Check and see if it's going to be a precipitate. If it is not a precipitate reaction, if these are all aqueous, then that means no reaction will occur and you can skip that one. So you're only doing the full and net ionic equations if there's a precipitate. If there isn't a precipitate, you can't do the full and net ionic equations for those because no reaction is occurring. Okay, that's it. Please let me know if you have more questions.